Okay, everyone, thank you so much for coming to the WAsmcloud February 24th, 2021 community meeting. Today, we've got a great book, great demonstration of the wash CLI from Brooks. So I'm going to go ahead and turn it over to you, Brooks. And again, this is WAsmcloud from sketch to scale in seconds.
Thanks, Liam. Yeah, I'm going to be showing you all a demo today that I like to call the Wash 101 demo. So showing you through what Wash is, which is a bundle of command line tools that simplifies WAsmcloud development. I'm going to dive into all the utilities that Wash has to offer by showing you what it looks like to build and sign an actor, a capability provider, and then using the Wash integrated REPL to start your WAsmcloud development journey, actually launch these things and get them running in a host. So that's the stage. As a couple of prerequisites, I've packaged this demo, all of these demo resources into a repository, which I'll have Liam link in the chat and in the video so that you can follow along later if you'd like to give this a try. But what this essentially consists of, I have a single actor and a single provider. And I'm going to talk about how you get from having this code initially to actually having these resources running in a WAsmcloud host by using Wash to make the rest of the development cycle easy. So to get started, the first thing that we need to do here is build and sign our actor. So this actor is going to be a WebAssembly module, a single stateless unit of compute, and it's going to be fairly simple. It's going to accept HTTP requests. It's going to act as an HTTP server. And whenever it receives that request, if it gets a message body of ping, it's going to respond with pong. So I've aptly named this actor the table tennis actor. So this is the Rust actor for WAsmcloud. Most of this was scaffolded out beforehand, so it's very simple. I'm keeping the code simple today to focus on the commands. So here, in order to sign this actor, we use the claims command. And the claims command is used to manage the claims, the additional information that we use to sign WebAssembly modules. And we do this signing because we like to have a certain level of verifiability for our WAsmcloud actors whenever we run them. We want to know where they came from, who signed this actor, what version it is, what kind of capabilities it'd like to use. For example, here, like a WebAssembly module can't make network requests or receive network requests natively. They need to use WAsmcloud capability providers in order to do that. So we use the signing process to declare that this actor needs an HTTP server capability. So to get started here, we can use the integrated help text to get a better idea of what we're going to be looking at. So to sign a WebAssembly module, there's a couple pieces of information we need. We need the actual WebAssembly module, which we're calling source. We need a name, which is just a human readable name so that we can identify it. Any capabilities that's going to make use of. So our actor is fairly simple. We're going to make use of the HTTP server capability, the WAsmcloud one. And the last thing that we need are to actually sign this actor with signing keys. To keep this brief, we're using ed 25519 keys. You don't actually need to care about the specifics of those keys. We have more information in our architecture decision log of why we chose to use them. But the two that you need to sign an actor are the issuer key, which shows what this actor, who signed this actor, what entity signed this actor, and the subject key, which is a unique key to identify the actor itself. So the great thing about Wash and using Wash claims is in order to sign a WebAssembly module, you can directly manage these keys, or you can allow Wash to generate these for you. And so I'll show you that in a minute. So to start, I've already gone ahead and built this actor beforehand to save us the Rust build time. But we can use claims to sign this actor, which I've compiled for release mode, just the WebAssembly module. I'm going to name this actor.
Just a bit, Brooks. I think you're down at the bottom, so at least on my screen, I can't see the bottom line that you're typing.
Oh, you can't? Okay.
Type clear and return, Brooks.
Boom. Thanks for pointing that out. I'll keep that in mind for the rest of the stuff too. Okay, so we can sign this WebAssembly module. I've already compiled this, as I said, for release mode. I'm just going to name it table tennis. And then the next piece of information that we need is the capability contract that the actor needs to function, which is HTTP server. And you notice here, as I was mentioning, we actually get to generate WASH will generate these keys for you if you don't supply them. So an account key for myself and a module key for this actor has been generated automatically. Now, this is great for the initial developer experience because you don't have to deal with a key format that you may not have worked with before. If you'd like to manually generate your own keys, which will eventually happen when you're working in a different environment other than local, we also supply a command called wash keys, which is for generating and managing these signing keys. So if we use wash keys list, we can look and see all of the keys that I have generated locally, which is in just a local wash directory that we base off of your home folder. And if I'd like to generate a key, I can do that manually too. So wash keys gen, and then the specific type of key that we need here is a module key for an actor. And we can see that that gives us the public key and the seed key for that we can use for this actor. Now the seed key is private, so make sure to keep this secret. Don't record a demo of you generating this and then holding on to it. But here I can use this fine for just demo purposes. I'm gonna scroll back to that same sign command. And if we manually give that subject argument with the signing key, we can essentially sign that actor again and use the wash claims inspect command to take a look at this signed WebAssembly module. So I might be going off screen again here. So I'm just going to do this again. And you can see here that the module key now has the same public key that we generated in a previous step. So
Brooke, I think you kind of glossed over a little bit of the linking capabilities there.
Yeah, I'd love to talk about that a little bit more. So when you sign an actor or when you sign a WebAssembly module that's built for WAsmcloud development, you take advantage of capabilities when you need to access functionality that you can't do from within WebAssembly. The example here is receiving or sending HTTP requests. You can use a capability like an HTTP server capability to be able to receive HTTP requests. Same thing can happen for like connecting to a database or accessing files locally on disk. This is a limitation of WebAssembly not being able to do these things natively, but we actually enjoy the limitation there, and we take advantage of it by being able to sign actors or and providers with these capabilities. We get granular control over what every WebAssembly module is allowed to do. So here you can tell immediately from this table tennis actor that it is going to act as an HTTP server. It cannot access files on disks. It can't make its own HTTP requests. You can see right at the top level what it's going to do. And this is great for verifiability that any actor, or say you run someone's actor that you don't know what their code looks like, you know they're not going to be able to access something that they're not supposed to. Does that kind of help explain there, Liam? Did you want me to go into something else?
No, I think that covers it. I really just wanted to make sure that everybody following along kind of understood the detail there.
Yeah, I think when we do a WASH 102 type of a demo, we can get into more detail on things like provenance chains and how you might set up that kind of verification.
Yeah, and certainly all of that will be published over at wasmcloud.dev with our documentation. Well, cool. So I'll keep going here. This has been a decent amount of, I've been walking you through the claims and the keys command. I didn't mention that I actually generated this actor from the new actor template that we have available on GitHub. And what this actually comes with is a Makefile to keep all of this even simpler. So this Makefile simply cargo builds and then signs the actor essentially with the same command that I just ran. So we can run make release when we're in this actor directory, and that'll build and sign the WebAssembly module for you. So the first time you're doing this, you can easily use this Makefile. Now, in order to keep things simple for later, I'm just going to copy the signed WebAssembly module up to the top level in this demo folder. And the next step is going to be signing our provider and creating a provider archive. So with providers, there's two problems that we're solving by using the par command for wash. So the first one is that we want the same amount of verifiability for a provider or a capability provider that we do an actor. So who signed it, where is it coming from, what provider is it, for example. And with native capability providers, without going too far into it, they are built specific for a host, like an architecture and operating system pair. So when I build a provider or a capability provider on my machine, it will work on my machine, but it won't work on a different architecture, for example. So what provider archives allow us to do is gain this verifiability by embedding claims, same way with, or embedding, claims, just like what we do with an actor. And we can have multiple different architecture versions of this capability provider. Today it's going to be simple. We're just going to make one for the local machine. So the process here is going to be largely similar to signing an actor. If we use wash par create, this will be the command that we use to actually, here, I'll do this again so you can make sure to see. This is the command that we use to create a provider archive. Same with the actor, I have this pre-compiled for release, but we just need to provide a few different flags here to denote what this provider is. Can you all see the line that I'm typing on right now?
Yep.
Okay, great. So the first argument that I'm going to need is my architecture pair, which I'm running on x86 on Mac OS. This may change for you depending on what like operating system you're on. I need to give it the actual release binary for the HTTP server capability provider. In my case, it's the shared object is a dylib on Mac. The next thing, I need the capability contract that it's going to be fulfilling. So this is an HTTP server. So the capability contract is WAsmcloud HTTP server. And this is how later on, when we use this actor and provider together, they know how to communicate with each other. We can give it a name, which I'm just going to call it HTTP server to keep it simple. And the vendor is who's going to be signing this. This is just for human readability. So I'll sign it from me. Now, another thing that you see here, hopefully you can kind of see it at the bottom of the screen, is we are signing this capability provider with another key that's been auto-generated for us with Wash. And we've reused the account key or the issuer key that was already generated for us. So if we take a look using Wash keys at what keys we have now, we have a module key for our table tennis actor, an account key for myself, and a service key for the HTTP server provider. So another thing that I actually, so if we look in our local directory now, we now have this WAsmcloud HTTP server par. Similar to claims, we also have an inspect command for the provider archives. And with this, you can see our generated public key. You can see that this provider archive or the providers in this archive are going to fulfill this contract ID. And we support the x86 64 Mac OS target. So this is going to work on my machine, may not work on a different architecture or operating system. The great thing about provider archives, though, is that we can include additional operating systems or additional targets within them. And that's actually exactly what we do for our first party providers. So Wash par inspect and Wash claims inspect both support remote inspecting of provider archives and actors. So if we take a look at the official WAsmcloud HTTP server artifact here, we can see similar claims that come out of it, but also a multitude of architecture targets. So these provider archives, for example, when you use our first-party ones, will work the same on many different architecture targets. Now that I have this built, I'm going to do the similar thing and copy this up to the top of the demo directory.
I want to clear the screen again.
Oh yeah, absolutely. I'm just, all I did was copy this up to the top of the demo directory. And I actually did want to take a pause here. We've gone through the claims, the keys, and the PAR or provider archive commands. And it's kind of a lot of information, especially with signing keys. So does anybody have any questions?
So I have kind of a general question that relates to the Makefile that you've got up right now.
Yeah.
So appropriate for right now, or do you want me to hold on to it?
Oh yeah, but
so I've noticed with the new project template, like the Makefile almost entirely delegates to cargo. Do you guys have any opinion on cargo make and just moving more things to the cargo world and dropping Makefiles altogether?
we actually have, there was another comment to use a just file, which is like similar to a Makefile, but built with Rust. And I'm not familiar with cargo make and if that's automatically included with cargo, but
it's not.
Okay, then a great benefit of having a Makefile or using Make is just like the sheer number of machines that come with Make prepackaged, which is great. But I don't think we have any hard opinions on using Make or using
really have a strong opinion either way. The ultimate deciding factor is whichever provides the best developer experience is probably where we'll go with it. But yeah, we basically just we settled on Makefile because we needed to pick something, and it was the most ubiquitous thing we had access to.
You know, with the WAPC CLI for building capability providers and the whole contract-driven development, we also were relying on a sort of model make microservice kind of workflow. I can see some advantage where ultimately all this will be hidden behind Wash, or like some high-level, really slick experience as we get there. But I think it's a great thing to consider if there's a better experience.
What was that other task runner? Just, you said?
Yeah, it's called Just. I think it's developed by somebody named Casey on GitHub, but it's essentially you make a Just file, which is just like a Makefile. Its goal is to remove some of the pain points of Makefiles, but it's very similar in function. The obvious downside is that to use a Just file, you need Just installed.
Yeah, if you look at the repositories that the people that are making Crustlet use, I think they favor Just for a lot of the work they're doing.
All right, cool. I'll take a look at that. Yeah, Cargo Make has plenty of quirks.
Yeah, the team, I mean, you can ask Radu offline or something. The team has settled into what the PM here will describe as a profound Just fetish. So right now they're very positive about it. Probably have to ask them for details.
Cool, thank you.
I'm glad we have the power to edit that comment out, Ralph. Thank you.
Excellent.
We need a WAsmcloud after hours. All right, well, I'll go ahead and keep going if there are no other questions, get through this demo. So we've gone through, we've built our actor, built our provider, and signed both of them. The next step is going to be getting these resources into a local OCI registry so that we can actually run them with WAsmcloud. So to keep this simple, we're going to use a Docker Compose in this tutorial to launch a local registry. What this does is just launch a registry image, makes it available on port 5000, and launches NATs, which is used for the WAsmcloud internal components to talk to each other. For now, this is great for getting a call and letting us run the required resources for Wash to be able to run a WAsmcloud host. So I've included this Docker Compose in this demo repo, and it's also available in the Wash and WAsmcloud repositories too. So this is pretty readily available. So using Docker Compose, I'm just going to detach this so that I can keep using the same terminal. Now we have a local OCI registry and NATs running, so we can easily continue this demo. In order to interact with OCI compliant registries, we use the reg command with wash. You have the ability to pull artifacts and push artifacts from and to registries. Here, the first thing we're going to need to do is push our actor up into this registry. So if we take a look at the push help text, then there's a couple options for connecting, authenticating to registries. Since this is local, it's fairly simple. So we just need to push to a URL and note the artifact that we want to push. So as I said, this is at localhost 5000. I'm going to push my table tennis actor to 0.1.0, which is just the tag of the artifact, and then send my table tennis signed WebAssembly module. Now, Wash will actually verify that this is a signed module. If you don't sign it beforehand, you'll get an error here. And this is to ensure that you're always pulling valid signed actors and providers. The last thing, we're adding the insecure flag, which is just because the local registry talks over HTTP. So we can push that to our local registry. We can also verify that that worked by inspecting the claims at this OCI artifact. And you can see a similar output to when we inspected the module before. Including the capabilities and the signing keys, which again is really useful to know before you download or start running an actor in your local WAsmcloud host. Now we can do the exact same command for our provider archive. I'll push that to HTTP server, same tag to keep it simple. And now that has been pushed to our local registry and ready to be pulled down by a WAsmcloud host. If we'd like to verify that these actually got pushed correctly, we can do a full round trip by pulling down one of these and comparing it. So this is all fairly quick. It's going to pull out as HTTP server, and we can compare these two provider archives here and see that they are the same archive. So we've successfully pushed to our local registry and we're ready to launch a WAsmcloud host. Now, this is the most fun part of the demo, which is actually getting to see code run and code work. So now we're going to move on to my personal favorite command, which is up, which launches a fully interactive WAsmcloud REPL. So this environment, you're able to use all of the subcommands that I've gone through so far in the demo: claims, claims, keys, par, for example. You can do that all within the REPL. But for now, what we're going to need to interact with the embedded host that's running in this REPL is cuddle, which is how it's pronounced, and it's short for control interface. This is how we actually interact with the embedded WAsmcloud host. So to get an idea of what hosts are actually running, we can run cuddle get hosts to get this single host that is embedded in the REPL, which is what we expect. We can also take a look at the inventory of this host by copy pasting this host ID here as an argument. And we can see two default providers, a couple of labels, but nothing really running on this host yet. Luckily, running things is fairly simple. We can use the cuddle start command to start an actor or a provider. So starting with actor, we'll give it the OCI reference of our table tennis actor. And we'll get an acknowledgement back pretty quickly that that actor is starting on the host. Taking a look at the inventory again, you can see our actor ID and our table tennis actor is successfully running on this host. Now, the awesome part about this is we now have another phone call, and we now have a actor running in this host. It's just a WebAssembly module. Normally, it cannot, in order to run this handle ping function, we need to deliver an HTTP request by starting a provider, linking a provider, all of that. But what we can actually do is we can directly invoke operations on a WebAssembly module by using the cuddle call command. Now, this is a fairly simple command to use. We give it the actor ID of the actor that we want to call and the operation that we want to call on the actor. So the operation, or what an operation is one of these functions that we've registered as a handler in the actor. For our case, we've only done one, which is handle request. And if we take a look at some of the docs here, just to give you an idea of where this comes from, we can call the handle request function and pass it an HTTP request and directly get a response back without actually going through the HTTP server provider. Now, the hardest part about using the call command is that the argument that you need to give it is the exact payload that the function is looking for, in this case, an HTTP request. So we need to give it all the fields and matching types, or else the actor will reject it. So I'm sending a post request with the body of ping, and the call response that we get back has a couple of message pack bytes that are going to show up as glyphs here. But the main thing that you can see is that we directly get a response back of OK and a body of Pong, which is awesome because we can see that our actor, our WebAssembly module, is handling these requests properly without ever even linking or starting a provider.
It may not seem as cool to everybody as it does to me, but I love the fact that we can specify the input to this function as JSON, even though the actor itself is only communicating over message pack.
Yeah, it is. It's awesome. It's great for a rapid feedback loop because you don't need to spend the time starting a provider and linking it too.
Well, I think there's a totally undersold story here around the ability to compose and test your business logic independent of how you're implementing it. You know, like if we think about this as a type of testing here, you know, whether it was unit testing or, you know, whatever, you know, this is like as focused of a test as you could write, even before we introduce complexities of providers. That's pretty powerful.
Yeah, 100%. Because here, you know, I have my actor that I'm using locally, but in a normal case, you're probably not going to go through this effort. If you just want an HTTP server, you can use the WAsmcloud HTTP server. And if you think that our code is super bad and you don't want to run it yet, you know, you want to test your pure business logic that's in your actor, you can do that without actually starting our HTTP server.
Yeah, actually, this might be a quick, short road into unit testing, is just the ability to send JSON to an actor and have wash, cuddle, or whatever output JSON back, and then just wrap a quick test runner around that. So you can have your test cases be JSON.
It's an excellent idea. We should totally look into doing that. I was just thinking as we were running through this wash, as we were walking through the REPL, that there might be a way to leverage some of the stuff that we've already done inside here to make it easy to run quick and dirty tests on actors.
That would make for easy generative testing as well.
Yeah, I mean, really all we need to do is define the payloads that it expects in response from the dependent providers. So like in our canonical example, we have the KV counter that makes a request of the KV store in response to an HTTP request. In order to test that, we could basically just supply a list of responses that it expects to fake from the the key value store. We could, essentially have, we could create a simulator for each of our regular capability providers, and then just load the test runner version of the provider.
Yeah, and you can with anything running in production-like environment, you can have you can shortcut some of the responses and gather inputs and outputs, and then run those on future versions as regression testing.
And I think, again, to Liam's point, there's some subtlety that's going on here that I think is easy to forget. One of them, the subtle points here, is that while what Brooks is doing is talking to a local host, if his NAT server was a leaf node connected to a lattice with 300 other hosts, he would be able to do exactly the same thing regardless of where those actors are running. So you can call an actor from your laptop, even if it's running in some other cloud environment.
That comment about, saving things from production reminds me of, sort of like marrying Postman and like something that like Darklang was trying to do, where, you would, as you submitted requests, you could like go back in time and play them. I definitely think that there's
they called it like TraceDriven Development, and I think we have the same ability to capture all of the payloads from a production run, and then allow those to be read from simulated providers. So yeah, I think this is something we should spend some time looking into.
Yeah, awesome. Just to drive the rest of the demo home, now that we know that our actor is working appropriately, we can do we can continue to utilize the control interface to start our HTTP server provider. And as a cool example, we can actually start the HTTP server provider from the WAsmcloud Azure Container Registry. The actual Azure Container Registry. And if we take a look at the host inventory here, once this has enough time to download, we can see that we have our table tennis actor and the official HTTP server provider running in our local host. The last command that we need is to link this actor and this provider together on a capability contract. And that way, HTTP requests can be forwarded from the provider to the actor appropriately. So for cuddle link, we just need to input the actor ID, the provider ID, and then the contract that we're going to be communicating over, which in this case is WAsmcloud HTTP server. And then we can also give it a port to listen on locally so that we can make these requests like just in another command line. Now that we've done that, we can simply open up another terminal. And if we curl localhost 8080, I'm going to make it verbose because I know what it's going to do. We get a bad request, which is exactly what's supposed to happen with this actor when we don't give it a body of ping. So if we do that again, but with the ping body, we're going to get our pong back. So now we've fully connected this to an HTTP server using cuddle link, and we can interact with this actor as a regular, just as like a regular HTTP server API. Now, last but not least, to get the very last command done for Wash, when we download resources from remote repositories, we actually cache them locally. And this is great for continued commands if we start the same provider over and over. To ensure that you're always getting the latest version of a provider or an actor, we also have the wash drain command, which is great and punny. And using wash drain, we can clear out any downloaded or cached binaries or OCI references that we have. So that is a pretty high level walkthrough over all of the commands that we use with Wash to make WAsmcloud development easy. There's a lot of functionality that's made simpler, including signing keys and using the control interface and the REPL to directly run these resources as a WAsmcloud program. So I'm happy to answer any questions or any feedback on how we can continue to make this easier.
All right, Brooks, thank you so much. That was incredible. So does anyone else have any questions along the way or comments? Did everyone follow along? Would a laminated glossy cheat sheet for WASH be handy? What's your kind of feedback here for people that are seeing it all together?
Personally, I've seen how all of this sausage is made, and it's still super impressive, and I love this demo. So really excited for the experience we have now, and then to watch it get even better and smoother.
Yeah. Steve, you're relatively new to the sort of like the life cycle of WASH and what the goal is. Does it make sense to you? Is it intuitive?
Yeah, I think it's really cool.
Okay, good. All right, great. Well, I had, does anybody think that we would need or want like, like a flow chart or a cheat sheet or something like that, like a little, handout, or is that superfluous? Does everybody in the call, would anybody in the call use something like that? Jordan, okay.
And I've built one for myself. I use them a lot. I'd probably use one that you guys build because it would be better than mine.
Careful. Let's not jump to conclusions here, right? Like, I mean, look, who's probably going to build it. Okay, super. Well, I'll take a pass at something like that. I was toying with some ideas last night, but I wasn't sure. I thought we'd kind of see how the demo goes. Well, that was incredible. Let me share my screen and we'll go back to the agenda if there's no more questions or discussions. But I really would just comment. Sorry, go ahead. Roddy, did you have something?
I just want to say it's a really well put together demo. It's going to be interesting to see as people start using it more, maybe which of the steps could be hidden by the CLI and which could be optimized. I mean, just give the option for the users to manually execute them if they wanted to, but hide them behind some flags or some auto-generated keys or the entire infrastructure. But it's a really, really cool demo.
I don't know if you were on the call we were on a few months ago where we did that, but if you think back to where we were in August, it was like, okay, now switch to N keys, and now now we're going to switch this command line utility to upload and download, and that's where we sat down and we really, and even the whole keys workflow, I think that was up on our Slack where we were like, well, why the hell do we and people generate keys? Let's look, if they don't have it, let's just generate it for them and just make all this stuff as easy as possible. How many steps can we just cross out of this process on the journey from sketch to scale?
Yeah, I think we want to make it so that we default all the easy things to the best possible path, but then let those defaults be overridden with more opt-in complexity if you need it. But like you said, the easy path should be for us to anticipate as much of what the developer needs as possible and go ahead and do it for them.
Awesome. Brooks, and I'm sorry the recording messed up. I'm going to have you do that again if you don't mind.
Great. So the first step is to sign your act.
Actually, you have to do it backwards this time.
Didn't even hesitate. He just dropped right back. He's a pro. He would talk to an empty room. He'd stand on stage on an empty room and be like, the first step is amazing. I love it. All right.
So I think this might not actually be the real Brooks. We might just be talking to a Brooks that he previously recorded.
Totally fair. I hadn't considered that possibility yet. Okay. All right. So some quick community news here. CFP for WASM Day has closed. I think there were 24 submissions, Kevin. So we'll start working through that as quick as we can and get some feedback back out. Tickets are still on sale though, so everybody look forward to that. That is May the 4th. WebAssembly Summit is fast approaching, April 22nd, and WASM Time weekly meeting was last week. A lot of fun stuff happening there. The notes are linked in our call if anybody wants them. Just open call real quick. Any additional community news? Anybody have anything going on they wanted to share, or events, meetups? Okay, super. One question I had from last week, just to carry over, was we had a great discussion last week about the current assumption that Nats is already running in the background. Kevin Brooks, did we get this captured on our as issues, things to sort of talk through and think through, or get these documented out well?
Yeah, we started, we captured it kind of under the broader issue of starting an actor from nothing is, has too much friction in it right now. So one of the areas that we can remove friction is to not require Nats in order to start the actor using the wash REPL. So I think we have a pretty good idea of if we make it so that the wash REPL allows you to start a no lattice host, and then all of the previously remote control functions can instead opt to using the host API to directly control, then I think the combination of those will mean that the new offline default would make it so that you can start all of your actors and providers directly from disk and control them from inside the REPL without having Nats installed.
Okay. All right. I just wanted to, kind of resurface that one again. I know we kind of discussed maybe should we be lazy loading, this Docker Compose file in the background for people if it's not already up. But I think some more user experience stuff to think through on that particular angle. And I see we do have a ticket for this, so I'm just going to go ahead and just delete that from our notes for this week.
Yeah, I think rather than the idea of lazy loading, which is sort of bringing it up on demand, we should just sort of have a default that is offline and no lattice and no Nats. And then if you want to use, if you want your REPL started host to be part of a lattice, then you just specify the lattice connection string. If you want your REPL started host to be part of a lattice and controlled remotely and so on, and you just sort of add those features.
Okay. Runtime configurable. Okay. Yeah, I think that does make a configurable. I think that does make a lot of sense. I think everybody has seen or had a chance to play with the new WASmcloud.dev and all the features here. Really excited. Welcome all feedback on this or pull requests as you kind of get in. This was a labor of love to get this out. I would comment that the t-shirt window is still open. That's linked on Slack. I'll link it into our call notes. That will be open until Friday. Those are free. You can order. There's 4 different options. You can order all 4. You can pick out your favorite, but feel free to get those ordered. And those we'll close that order end of day Friday and get those shipped. But I think from an agenda perspective, without diving into issues and things like that, that was what we had. I'd kind of open the floor to see if anyone else had anything they wanted to bring up this week.
I think one other thing, we sort of talked about it when Jared brought it up, but I think one of the things that I'm going to take as a to-do item is to take a look at potentially creating a universal test provider that we can use to slot into a test running host and then, essentially run our tests against fixed or pre-recorded payloads. And I think that might dramatically reduce the complexity and the cost of testing actors.
Awesome. I think that was a magical moment. I love the, I think that's one of the things when we think about if we want to build the best products, we need to have the most diverse and inclusive community, like the principle of having the biggest tent possible, because the best feedback and ideas comes from the most diverse perspectives. And that was awesome. And it's stuff I know that we have at times kind of like talked around, but that moment just really, I think, crystallized a really solid idea that we should absolutely just get pinned out on our roadmap out there. Back to open floor. Anyone have anything they wanted to bring up Radu, Ralph, Wicker, Steve, anybody?
I don't have anything specific to bring up. I love the demo. I do like how the experience is coming along. So in this case, I'm just riding. Oops. Can you hear me?
Can hear you now.
All right. So I was just saying I was riding the demo and enjoying it. I liked seeing how the experience is coming along, and it's just, it's really rich. But outside of that, I'm surfing the hour today. It's just a pleasure to be here and see what's going on.
Okay, awesome. All right. Well, Wicker, did you have anything you wanted to throw in and add?
I just wanted to thank you for inviting me, and I think the demo was really awesome. And one of the things that I just want to share what we're working on at WASMer, like what our next big thing is going to be. As you know, we recently released our runtime that we'd love to make a part of WAsmcloud. So we'll figure out how to make that happen. I know, Liam, I think we owe you a pull request. And then the second thing that we're working on is going to be the next release of our package manager. So it's currently kind of like pre-alpha-ish quality on our end. And we want to, as things like WASMcloud come along, we want to kind of give those packages like a proper home with proper functionality. So if anybody has ideas that they want to share or things that they wish package manager would have, I'd love to hear them.
All right, that's awesome. Thank you for keeping us up to date on that. Anyone else across the community? All right, I'm going to go ahead and stop recording, and as usual, we can turn this into WASMcloud After Dark.